Hello, in this paper titled Strain-Modulated Reactivity and Acidic Silane by Moret et al., I am going to present you a strained silanide acid-base pair using Stris methyl phosphonium scaffold abbreviated as TMPSi. As you can see the silhouette in the background, this is the TMPSi. This chain TMPSi is an attractive competitor of well-established transition metal complexes as these are inexpensive green catalysts formed from elements abundantly found on the Earth's crust. Before moving on to the previously done researches using strained silane, let's get introduced to the release Lewis acidity. So it has been observed that forcing non-trigonal geometries at phosphorus 3 center can give it as an electrophilic as well as nucleophilic character arising from its lone pair, which has been used as unusual bond activation. In this picture, you can see that this is a Denmark uh, strain release Lewis acidity is based on the fact that angle strain is partially relieved upon binding with nucleophile. Here, the transition from the tetrahedral geometry to trigonal geometry reduces the geometric angle requirement from 105 degree 28 minute to 90 degree. Using this strategy, both Lewis acid and Bronsted acidity can be manipulated and used in highly enantioselective CC bond forming, mode of which is given in this reference below. Bronsted acidity of SiH is rare due to its general hydridic nature of Si and H. Previously, Krempner et al. And Beckman et al. Synthesized Bronsted acidic SiH relying on the electronic effect. This paper report a very low pKa in DMSO lying between 4.7 to 8.1, which is more acidic than that of phenol, benzoic acid, and other reported silanes. Synthesis. Uh, Using diisopropyl phenyl SiCl2 uh, as an silicon 2 source reacted with tris indolic salt T abbreviated as TSMPK2 to form deuterionic silanide TSMPSi. This silanide was protonated using Bruchert acid, which is HBA tetrafluoroaryl 2E2O. Intraceable mixture of insoluble product obtained when it was protonated with HCl, highlighting the importance of non-coordinating acid in this reaction. Moving on, the X-ray crystallogram. The crystals were grown. The crystals of the one TMPSi1 was grown in benzene n-hexane, while the crystals of 2 TMPSiH plus were grown in DCM 1,4 dioxane mixture. Structure 2 features a tetrahedral SI center surrounded by 3 dioxane within a distance smaller than that the sum of van der Waals radii, suggesting weak SiO interaction, which is the interaction between the O-centered lone pair and sigma hole opposite to the SiN bond. SiHO bond angle is between 82.7 to 92.1 angstrom near right angle. Thus, it is unfavorable for hydrogen bonding, suggesting that silicon center has Lewis acidic character. In the structure 1, TMPSI, the sum of NSIN angle is 277.5 degree, indicating high S character of anionic lone pair. So we know that the greater the bond angle, more is the S character according to the Bend's rule. Thus, the acidity of the withdrawing effect, the acidity and the electron withdrawing effect is significantly enhanced by unusually acute NSIN bond angle imposed by the heterobicyclo 2,2,2 octane scaffold, polarizing bond towards silicon, facilitating heterolytic dissociation. Thus, acidity of the reference acids were known in DMSO. The pictures are given below. Uh, uh, the cationic silane cannot exist in DMSO solution and degrade immediately. Given the linear correlation between the acidities in different solvent, acid-base reaction in the dioxane D8 was performed. Dioxane being a hydrogen bond acceptor, it could promote fast and efficient proton transfer. 2,6-lutetium boron tetraadyl salt, uh, abbreviated as uh, mm, uh, 6, was used as reference acid, while the CH acidic fluorines 4, 5 were also used as reference acid. The fluorines have been previously used to measure silane acidity, and their strongly delocalized anion are not expected to coordinate with silicon center. While fluoradene 4 does not promote protonate, silanide 1 fluorine 5 can undergo base catalyzed isomerization, giving a pale blue solution indicating presence of small concentration of delocalized anion of deprotonated fluorine. Now, using computational study, high acidity of cationic silane TMPSiH+ can be ascribed to three cumulative effects, which are electron withdrawing effect of indolic nitrogen, ring strain, and overall positive charge. There is an empirical dependence on gas phase and solution phase pK within same class of acid due to the free energy difference between the acid and base attenuated by different solution. Because of solution difference in neutral and charged species, the electrostatic effects are expected to remain significant but strongly attenuated in the solution. To assess the role of the positive charge in the TMPSiH+, natural bonding orbital analysis was done on deprotonated 2, that is uh, TMPSi anion. It was shown that anionic lone pair of silicon has predominant S character, uh, Sp 0.41 hybridization, and minor delocalization of 2% in the sigma star Cn orbital due to hyperconjugation. So the acidity of 2 does not originate from the increased delocalization of negative charge in the conjugated base, but from the electrostatic interaction between the deuterated charges. High acidity of a TMPSiH+ suggested stabilized anion of TMPSi, which should act as weak nucleophile. This reaction with iron salt seemed to be solubility driven, as no complexation was seen. These are the figures 7 and 8. Reaction of TMPSi with methyl triplet yielded cationic cage compound, which is the compound 9. Unexpectedly, on exposing TMPSi with only zero point 0.1 equivalence of methyl triplet, resulted in complete isomerization to charge neutral iso TMPSi, which might be phosphorus bound methyl group lost from the either from TMPSiH+ or TMPSi methyl plus to reduce the strain of the cage structure. Uh, this might be the additional driving force for this strain release methyl transfer complex. Reactivity of the silane was proposed to be resulting from the pentacoordinate silicon center and suggested to pass through some fluxion process like Bery pseudorotation or reversible dissociation. Now, small the 31p NMR signal shift from minus 7.6 ppm in DCM to 7.0 in THF ruled out the THF interaction with the phosphorus plus center. 11A, the THF ring opening product was spectroscopically identified. The fluctuationality of THF ring opening was illustrated using variable temperature NMR spectroscopy. 11A and 11B display only one 31 NMR peak, This exchange mechanism can be thought as of two consecutive berry pseudotype rotation. NOE spectra indicated the comparable free energy of these isomers from 11A to 11E and presence of the structures 11B to 11Z. At room temperature, the strained TSMP platform allowed to access 4 and 5 coordinate geometry and facile interconversion from Si2 and Si4 plus species. Thus, concluding the SiH group reactivity can be greatly altered by enclosing it in a strained bicyclic scaffold, resulting silane being more acidic than that of phenol, benzoic acid, and few hydroxysilane. It can also be shown that strain release reduces acidity in coordination with THF, activating weak nucleophile. This ring opening product shows high degree of geometric functionality. Thank you.